Hi, this is Chris Cohn and Zain Ali from Graphics, and we have another video to show the actual layout and verification in this full flow environment provided by the new PDK updates in the eBeam PDK. And so what we wanted to show is using this interferometer that you created earlier in the first video, or that we created, you can use that schematic to drive your layout. And so the way you do that is you generate and create your layout from Project Manager, and then you use your DLA palette in order to auto-place these cells. And you can do it really fast, and there's a setting inside of Pixus that allows you to actually place your cells so they match the orientation and I guess proximity to other cells that you have in the schematic. And so that makes things really handy. And then once you go in and do that, you can actually start to move things around. My favorite command is move relative, or you can type in MOV space RE and then space the actual X and Y values to do that. And then once you place and position everything as you need it, you can actually go in and run iRoute in order to kind of check out the total lengths of your waveguides. And so I think we've done that. We wanted to make sure that we have a 50 micron or so length for your base waveguide to match the schematic. And then we've got like a 200 micron or so length. So we have to add 150, I guess, this little bin in this whole area. And then, you can actually look at it, do a Q or edit the waveguide, the path using the Q hotkey in the edit object area. And then you can view the total length and you can modify that. Once you do that, you turn that into a waveguide using the make PWG utility. And even then, there's bins in it now, so the waveguide length actually got a little bit shorter. And so you can kind of adjust things and fine tune it, and then use the N hotkey to select the waveguide and then check out your total length. In this case, it's about 200 microns, and then you're good to go. So you can complete your routing. And then when we complete our routing, we need to add the interface text. And so we have a pull-down menu, add interface port and text. And this specifies to Calibre where the ports are. And those are the ports that are matching the ports on the schematic. And so once we do that, we can run Calibre LVS. When you run Calibre LVS in this full flow PDK, LVS is set up automatically for you. And so all you have to do is press the play button, or actually the run LVS button, and you should get a clean result. And if you don't, what you can do is actually use RVE to debug your results. In this case, it looks like we have 2 nets in the layout, 1 net in the schematic. So I think we missed a route. And so that's easy to fix. You fix that using iRoute. And so use the iRoute utility. And then right mouse button click to make the waveguides. And then do another check inside of Calibre Interactive for LVS. And hopefully this time we should get a clean result. And in this case, we get a happy face. We're ready to move on. So the next part of this verification video is we wanted to go in and actually generate the post-layout extracted netlist. And the way you do this is you use this deck called lvs_extract.cal.encode, change the inputs to use netlist extraction, and then for the layout netlist, call it interferometer.spi. So what this is going to do is when it runs, it's actually going to extract the Calibre or the layout netlist along with the waveguides. And you can actually view this netlist inside of the Calibre RVE netlist viewer. Double click that item, and you can dive down and you can actually turn on the device properties and then view the individual waveguides. In this case, there's our 200 micron waveguide. We can actually highlight that, cross probe it back to the layout. And that's it right there. That's very handy when you need to kind of figure out where you are in the design. And so now that we have this netlist available, we can actually go on to the next step. That's going to be the next part of our video, where we take this netlist and we register it inside of Pixus. We'll register it to a symbol, and then we'll be able to run this in Lumerical Interconnect. And actually, before you run it, let's go ahead and you can use the date modified attribute in Pixus Project Navigator in order to make sure you have the right netlist. And you can view the netlist in the default editor. Here you can see there's extra properties, $X, $Y, $D. These aren't understood by Lumerical, and so we have a utility called Prepare Netlist for Interconnect. So if you select that netlist, you run this utility, everything should be pre-populated in that GUI. You press OK, and that brings the netlist over into the area which you need to use to register your netlist. And we'll show you how to do that in the next video. And so again, this is Chris Cohn and Zain Ali from Intergraphics. Thanks for your attention, and please let us know if you have any questions or comments.